Okay. We'll get started with the Docker containers and little bit of comparison into VM, and then we'll do a deep dive into Docker commands, Kubernetes, like that, because we are trying to move towards containers, uh, containers and container orchestration tools. Okay, VMs and containers difference. We have already seen VMs are like having a multiple independent computers running on single physical machine. It is like on a physical machine, you would divide them into smaller pieces and allocate CPU, memory, storage, all that, and then you try to use the complete operating system for running your workloads. Okay. Can you answer me what exactly you do by running a virtual machine? It is for a server, running a server, right?
Yeah, Shankar. It
And
is same like one more OS.
one more operating system. And the purpose of your deployment would be running an app and giving access to people, access to public, and make money. So run your business, especially run your business. That is the whole purpose of running a server. Running a server, deploying an application, whatever it is, right? So people started looking at, what are the difficulties, what are the problems that we have with respect to running the server under the virtual machines. One of the reason why we went ahead with virtual machines instead of physical machine is maintain consistency to avoid unreliable services, and having good performance, and also more reliable services, more reliable applications running for the customer. At the same time, we are also trying to save cost and make it more secure. So with respect to VM, but directly running it on the VM, in any case, we'll be needing virtual machines for running our workloads. Without virtual machines, it is impossible because we need to virtualize our environment. Then only we will be able to efficiently use our resources. See, it could be large in size, high resources, overhead, all this, but we are not going to run our workloads directly onto the virtual machine. So that's the only difference that we are going to make. No services or apps running on VM. Rather, where are you going to run it? So one more point is not as system service. Understood? Any clarifications required? Srini?
So every services can run inside the VM, right?
Every service can run inside the VM, but the only problem is it is difficult to
Okay, a system.
orchestrate.
Not it is not like a system service. Okay, okay. It is like a separate machine. It is not like a service. Yeah.
Yeah. Those services or apps running on a VM. Uh, so I'll just correct the sentence. No services or apps running on a VM as a
Okay.
system service.
It's system. Yeah. Correct.
The goal is to run as a container service so that we can use our resources effectively. The main purpose of creating containers is to have a consistent environment that we already spoke about it, which is very, very important for our workloads because that was a major problem when you run using physical machine, when you use completely physical machines for your workloads. Way back in 2000s, there was no hypervisor, there was no virtualization. People used to struggle like anything. There used to be a lot of dependency on people. There used to be a lot of system administrators, a lot of people maintaining the data centers, local data centers. Nowadays,
What?
everybody is just moving on to the cloud without thinking about what is their data center cost, what is their upfront hardware cost. We just pay only for the EC2 instances and other network resources, but not for your data center, not for your maintenance of data center, not for hardware, not for the hardware engineer. You don't need to think about investing a lot of money to start a company. You can simply start a company just by creating a AWS account or any cloud account and create your resources and run your application. It has become super easy for people to start a new company. Isn't that right?
Yes, sure.
Yes, sir.
Okay. Containers, if you really look at it, containers are form of a OS virtualization only, right? I mean, it is also kind of a OS virtualization. The only thing is they don't actually run their complete operating system, but they share the host operating system information or the host operating system kernel, host kernel, but
Kernels.
they are isolated in their spaces. So you can think of workspaces. So workspaces concepts only comes into picture here. Okay. Pros and cons. Lightweight, it's very lightweight in nature. It is very quickly bootable. It is just within couple of seconds, your instance will be running, your container will be running. It will serve your traffic. More containers per host. That also you can run because it is going to hardly take probably 100 MB or 70 MB or 80 MB, not more than 200 MB overall if it is a decent container. But the only problem with this container is less isolation because potential security concerns if the host voice kernel is compromised. Okay, that's a problem because you're not able to isolate your container separately. If your host voice is uh, compromised and you cannot do anything. So what does it mean? What is host voice? Host voice,
If any load happens in the host,
yeah, correct. Basically, the machine in which your operating system runs, that is a host voice. Say, for example, Amazon Linux or Oracle Linux is the underlying operating system, then it all based on your operating system on your host OS. Container OS is whatever is running inside your Linux operating system, inside your host OS is called container OS. Containers. Okay. So here, imagine an apartment building as a physical server. VMs are like separate apartments, own kitchen, bathroom, living, like voice and other resources. This exactly the same example I have given you during the class. Containers are like sharing common kitchen and bathrooms, having your single room in an isolated user space. It is basically your hotel room in a city. Okay. Now I'll have to remove all this. Just a second. Okay. What is a Docker container? Basically, it's a container, a runnable version of your image. What is image? Image is something similar to the AMI, Amazon Machine Image, which you have it in AWS cloud. Similarly, every cloud has operating system image. Similarly, containers will have container image. From there, you can run your containers. Can you tell me where exactly container images are hosted?
Um, it could be local or registry.
Yeah, registry. It could be mostly registry, like a Docker Hub, Elastic Container Registry, Azure Container Registry. Like that, there are different places where your registries will be stored. Your container images will be stored. I'll just write it down here. So Docker Hub, ECR, or SCR. So like that. And otherwise, you can have it local. And you can also store it in GitHub, GitLab. I'm not sure GitHub has it. In GitLab, you can push your repositories. You can push your images. Okay, what is a Docker file? Docker file contains sequence of instructions, a series of instructions, which will create a container for the requirement. So, any idea what is a Docker file?
So it is like a JSON format. It would be
No, it's a plain text file.
okay.
Combination of instructions, Shankar, to create a Docker image.
Say, think about EC2 instance, right? What do you do while creating an EC2 instance? You install packages, run application. What else do you do? Probably configure few things and then access your application. That's what you do when you create a EC2 instance. For example, if you create a Docker container, the first place where you need to start is writing a Docker file. This Docker file is a simple text file which contains instructions similar to user data. User data, what is the user data here in EC2? It is nothing but a shell script that will take care of installation, configuration, running some services. All those things will be taken care by user data. Similarly, when you are creating a Docker container, Docker file plays a major role or a critical role where you need to define the first place what is the image that you are going to use, base image. And then you have to start telling what are the different commands that you are going to do for running the application. Okay. So you see that run apt get update, work directory, cd, copy. All these commands are similar to what you do normally in your day-to-day work. So all this information should be part of your Docker file. Say installing dependency packages, exposed port number. That means unless you expose a port number, you will not be able to access the container. So container is like it's an isolated service
Sorry.
unless you say that there is a service which is running, nobody can access it. It's like a daemon. It's like a standalone process that is running that is not known to people unless until you say that there is a service which is running which you can access through this particular port number. And the command is same as the normal command that you run in your Linux machine. From specifies the base of the image to use, what image that you're going to use, the base image, because we already have built-in image similar to whatever AMIs that are available for your EC2 instance. You remember using a AMI while creating an EC2 instance?
Yes, Shankar.
Yeah,
Yes.
even in the Terraform files, we normally mention what AMI that we are going to use to spin up a EC2 instance. Similarly, the base image must be used. There are a hell lot of images available in Docker Hub, uh, small Ubuntu, I mean, minimal version of Ubuntu, minimal version of other Linuxes, and all specific packages like Python, Django, like that. Everything is available. You can go and check it out in the dockerhub.com, hub.docker.com. Say, for example, hub. Dot, if you go here, you will see official images available here. See, Postgres, MySQL, Mongo, everything. So if you simply go to MySQL, you will see a Docker file. You will understand what exactly this MySQL. What does it contain? So how do you run your application? How do you run MySQL container? Docker run. Directly use your MySQL. This one. Whatever MySQL that you want to pull from the Docker Hub. You don't need to have a login or credentials to be passed because it's a public one. It's not a private one. It's a public Docker Hub. You don't have to specify any username or password to log in and pull it. So not
So these images are already created earlier, right? So only we are getting using.
see, that's what I said. Say why AMI is already available. Why are we doing some changes? Why don't you just run the EC2 by just calling the AMI and then run your service simply? Because you need to configure, you need to customize your operating system, right? Similarly,
Yeah.
you will be customizing your Docker container by putting your source code into the application. See, it is
Yeah.
not about just using the Docker images. It's all about
Okay.
how do you run your application. See, that's why you create a Docker file. This Docker image, this Docker image is a base image. It doesn't contain any application code or anything. Okay. So let's go back
Yeah.
here. So you put a requirements.txt. What are the packages that needs to be installed? See, for example, if you look at it, see work directory app, copy your content to the app. So this is where your application code is copied. For example, your war file, your jar file, your application
Hmm.
code, packaged code will be copied here. So what is a Docker image? Docker image is nothing but a build which is created through the Dockerfile. So you created a Docker file and you put your application code inside. Like that, you say that you will have the application code locally available also. Within that application code, you will have a Docker file. So when you run a Docker build, it will create a build and save it locally. Then you can probably store it in the remote using either Docker Hub or Docker Elastic Container Registry like that. So here, if you see this, a Docker image is a read-only template that contains the instructions for creating a Docker container. Okay. So Dockerfile is set of instructions to create a Docker image. The Dockerfile is a text file that contains series of instructions for building a Docker image. Again, the next one is Docker image is a read-only template that contains instructions for creating a Docker container. So that is a step. Step one, Dockerfile. Step two, creating a Docker build, Docker image. It includes application code, libraries, binaries, dependencies, tools, and other files needed to run the application. See, this is very important. This contains the complete application code, libraries, and other things in order to run the application and make it available to the customer. Images are built from Docker files. They are stored in a Docker registry. So mostly we store them in the Docker registry and do a Docker pull. So how do you pull the Docker image? Do a Docker pull and use a particular tag and pull it locally. Then you run the Docker image. You do a Docker run. So similar to this one, Docker run. This way you can run the Docker container. Okay. So any questions on how do you run a Docker container? For this, what we will do? Yeah, please.
No, Shankar, clear.
Okay. So what we will do is we will Dockerize the application, whatever we created, like Java app or Node.js app. We'll Dockerize that application and get it deployed into a simple single EC2 machine and then try to access a page through the container app. Okay. So the next thing goes is how do you create a Docker image and push it to the Docker Hub? So while you are creating the Docker image, after creating the Docker image, you should do a Docker tag. Docker tag means you are giving a tag or name to the particular image and then you are pushing to your. So you here your Docker Hub username must be there. So you have to follow the same instructions and you have to do a Docker login to the Docker Hub with your username and password. Docker login and then do a Docker push with your Docker Hub username and then image name and then tag. So we should follow exactly the same sequence so that you are able to push your Docker image to the Docker Hub. Later on, you can do a Docker pull. So for doing that, you should create a Docker Hub account, build the Docker image from the local machine, and push your image to the registry. We call it as repository, registry. Both stands okay. There's no problem. How to run a container? Docker run -d means run it as a daemon in the background, not on the same terminal. That's what it means. This is a host port. This is a container port. So host port, like I told you, without the host port, you will not be able to access your container. Container port, it says on which port the container is running. Especially if you design application, say simple HTTP application, you will run it on port 80. Any web application, people run it on port 80. Any Node.js application, people run it on 3000. Similarly, so Sonar Cube is running on port 9000. So that container port remains same for all the application, whereas host port you can change it to 8080, 8000, 8001 like that. So it depends on how you want to host your application as a container. People normally go with the 80 port, 880 like that until 9999. Okay, and your container name and image and tag. So D for detached mode, background mode. Hyphen makes a port on the host machine to a port inside the container. So this port will direct your connection to the container port. This allows you to access applications running in the container. Assigns a name to the container. That is very important because whenever you want to do some operations, you don't have to go with the container ID. You can go with the container name. For example, if you are, say for example, you are running this app with your username, you can do with the username. See container name, say here. Docker exec IT is to log into the particular container. How to view the logs of the running container? Docker logs your container name. You should closely look at it. It is a Docker logs, not log. Docker logs. Dash F means, what is dash F?
I think full.
It's what do you call it as tail.
Yeah, it will append the last lines, right?
Yeah. It is like it is equivalent to tailing your logs. Here we use dash F. Displays output as standard streams of the container. So every small updates will be just printed on the terminal so that you get to know what is going on. So Docker PS is to check whether this Docker is running, how many Docker containers are running. PS-A will show you all the stopped containers and all the running containers. Docker images will show you all the Docker images which are available locally. So what is a host port? What is a container port? Port on which container port is the port on which the application inside the Docker container is listening in for connections. The expose instruction in the Dockerfile informs Docker that application will use this port. Okay, got it? Host port, the port on the host machine that is mapped to the container port when you access applications from outside the container. You use a host port. So basically, so here it is. So -P 8080 8000. That is like expose 8000 and give 8080 as your host port. So container port 8000, host port 8080. When you want to access application, it is your host name or your IP address colon this host port. Then you can access. If you use 8000, you will not be able to access it. You can use a host port if you are running a container to access your application. So I would like to stop it at this point. If you have any questions,